Welcome to the Slop Temple. We pray this video helps.
You start by ensuring the environment is reproducible and ready. Install Python 3, 8+, Qt if using GPU, and create a virtualenv or Conda environment. Once done, place a clean dataset into /data and define train, validation, and test splits so you can iterate safely. Next, create a config. IML with model type, optimizer, initial learning rate, batch size, epochs, and random seed. These values let you control every experiment step and reproduce results exactly. You now set the training mechanics that determine stability and speed. Configure batch size for memory limits and choose a learning rate schedule. Use weight decay and gradient clipping to prevent divergence. Make your data loaders efficient by adding augmentation, shuffling, numworkers, and pin memory to maximize throughput. Once done, enable periodic checkpoints, mixed precision amp for speed, and a validation frequency so you can monitor overfitting. These middle steps keep training both efficient and reliable. You finish by running a full training run while actively monitoring logs, GPU utilization, and validation metrics to confirm progress. When satisfied, export the best checkpoint and convert to a serving format like ONCS or Torch script, then deploy behind a REST or gRPC endpoint with simple scaling rules. Finally, add monitoring, alerting, and periodic reevaluation. If training stalls or metrics collapse, a key troubleshooting tip: reduce LR by 10x, enable gradient clipping, and
Thanks for watching. Consider subscribing if we helped you.